Hey, Algebra 1. Amazingly enough, yes, this is algebra, and we're talking about banks and how banks pay you to provide their services. So, have you ever thought it odd that a bank pays you interest for the honor of looking after your money for you? Think about that. Like, if you put money in the bank, they actually pay you to look after that money. So throughout history, people had to pay banks to look after their money. But in the Renaissance, with the rise of world exploration, banks realized that looking after people's money was an incredibly good thing for them. They could make money off of the large amounts of money that they were keeping for others. They wanted to encourage more people to give them their money to keep. So they started paying customers. So basically, you give the bank your money. They actually use that money while they're holding it. They'll invest in things, they'll lend it out to people for interest, etc. So they'll pay you to hold on to their money. So banks, they originally computed in something that's called simple interest. And that's the type of interest we're going to study in this example. Simple interest is calculated at the end of each year on the original amount of money. And that could be either money borrowed, you could borrow the money, or you can invest. Oof. Too many eyes. Invest the money. And when you invest it, it's called, or both of them, sorry, they're called the principal. Principal. So we're going to use this example below, this example right here, sorry, to make sure that we understand the concept of simple interest. Whew, I had to sneeze. So we have to get a good grasp of simple interest because the next example is more complicated. So Kira has been babysitting since 6th grade. She has saved $1,000 and wants to open an account at the bank so that she earns interest on her savings. Simple Bank pays simple interest at a rate of 10%. How much money will Kira have after 1 year and 2 years if she does not add money to the account after 5 years? First of all, we need to talk about percentages. I need to change this percent into a decimal. So what I do is I move a decimal place over 2, and 10% is equal to 0.1. That's important. So simple interest means that I'm going to do $1,000 times 10%, which equals $100. And then I'm going to add that back to the principal. So after 1 year, she actually has $1,100. Okay? So this right here is the interest paid. That's how much Kira got from the bank for them to watch her money. So her bank account at the end of the year now has $1,100 in it. At the end of 2 years, she starts out with $1,000. Her interest is $100 after 1 year, and then another $100 after the second year. So this would be year 1, and this is year 2. So she has $200 in interest. I add that back to the original, and she now has $1,200 in the bank. So that is her interest paid. 5 years. Okay, before we do 5 years, I want to introduce you to the equation that we're using. This is I of t equals PRT. Okay, this right here, it's our function notation, and it actually stands for the interest earned after T years. Here, this stands for the principal, how much I invest or borrow. That is my rate. I need to change the percentage into a decimal. And this is the time in years. So I'm going to figure out the interest earned in 5 years. My principal is $1,000. My rate is 10%, which is 0.1, and my time is 5 years. Do a little math there. Interest earned is $500. If I add that back to the original, I get $1,500 she will have in her bank account after 5 years. Pretty cool. Right, here's what we did. So this diagram shows $1,000 invested, 10% interest for 1 year. I have $1,000 now. 10% of 1,000 is 100. This is how much interest is paid. I add those together. This is her total after 1 year. Now I've got $1,000. 2 times 10% of $1,000 is $200 interest paid for 2 years. Add that back to the principal, and I now have $1,200 after 2 years. We did. I ruined the fun. IPERT is how I always remembered it. You just don't have a vowel. So IPERT, but it's really I equals PRT. Ha. Okay, Raul needs $200 to start a snow cone stand for his hot summer. For this hot summer, he borrows the money from a bank, there's my principal, that charges 4% simple interest per year. So we're borrowing, and we have 4% simple interest. How much will he owe if he waits 1 year to pay back the loan? So I've got, I evaluated at 1 is my principal, times my rate, changed to a decimal, times my time. $8. So he's going to owe $208. He owes more than he borrowed because he owes the bank for the use of their money. 2 years, 200 times 0.04 times 2, $16. I did not need a calculator for that one. That is really silly. And then 5 years. Oh, skipped 4. My equation, I'm assuming that's going to be 32 because it's double of 2. Add that back in. I don't think there's that much incentive for him to pay that back quickly. It's not costing him a ton of money. And then 5 years. Yep, we're good. 40, so $240. Cool? Write a formula for how much he will owe after T years. Well, this is what we've been doing. These formulas, and this one's going to be explicit. Okay, I did this part each time, and then I added it back to the principal. So I added it back to the principal. That rate didn't change. The only thing that changed was my time. And I always have to set it equal to something. And I chose A for awesome. I have no reason. But that equation works every time because that's what we did here. We took our principal and we added it to our interest. So it's like principal plus PERT equals total money. So in the 1600s, banks realized that there was another way to compute interest and make even more money, because of course banks want to make money. With compound interest, banks calculate the interest for the first period, add it to the total, and then calculate the interest on the total for the next period, and so forth. So an example, I invest $1,000. In 1 year, I calculate 10% of that $1,000, add it back in, so this is my amount after 1 year. That's what we did last time, amount after 1 year. But second year, I'm actually going to calculate with my new amount, which makes total sense. I mean, why go back to the beginning each time? I now have $1,100 in the bank. So I'm going to calculate the interest earned off the $1,100 and add it. And this is how much I have in the bank. So it compounds. It builds up. Builds onto itself? I don't know. It adds up. Okay, compound interest. You make more money. It's better for the bank if they're lending you money, and it's better for you if you're investing money. So this pattern is what we're working on. Okay, this is called future value equals present value 1 plus to your interest rate in decimals and years. So future value is how much your money is going to be worth. Present value is how much you invested or borrowed. Rate is your interest rate in decimals. And then we've got time. Oops, and this time in years. Oh gosh. Haha. N is time in years. So that's the equation we're going to use. Okay, so highlight that, write it down, circle it. All right, Jack, one of my favorite names. Jack has $500 to invest. The bank offers an interest rate of 6% compounded annually. How much money will Jack have after 1 year, 5 years, 10 years? Okay, we are compounding annually. My rate is 0.06. This is my present value, and I'm trying to figure out my future value. So for 1 year, I'm going to do PV times 1.06. Let's show my work. 1 plus raised to the 1. 500 parentheses 1.06 raised to the 1. That was silly. Didn't have to do that. So I've got $530 is how much he'll have after 1 year. Now if I'm doing the future value, this is 1 year of 2 years, I don't have to redo my equation. I use the same one and I calculate it. So I'm going to go grab that equation and change that exponent to a 2, and I get $561.80. Future value after 5 years, I'm using the same equation with the same present value. I don't have to do anything special to my equation. This equation calculates my simple interest for me. I'm going to change that 2 to a 5. $669.11. Your money grows a lot faster when you have compounded interest, because at the end of every year, the bank is going to pay you interest on what you originally invested plus the amount of interest paid last time. So the bank calculates your interest a lot faster. 10 years, $895.42. Now, in your problem set, we're actually going to compare simple interest and compound interest between two banks. And you'll see that the compound interest actually makes more money after a while than the simple interest does. All right, you have $200 to invest for 10 years. Would you rather invest your money that pays 7% simple interest or 5% interest compounded annually? Is there anything you would change in the problem that would make you change your answer? So let's figure it out. Let's do this. Simple interest calculation and compound interest calculation. Now we have 10 years, So let's figure out how much interest is going to be paid in 10 years. IPERT, $200. My rate is 0.07 and 10 years. Oops. That is $140 in interest. So a total of $340 after 10 years. Compound. Future value equals present value times 1 plus rate to the time. I get $393.43. So I would go with the compound interest one. You make more money, right? I don't know, what would you change? I mean, I guess you could change your interest rate. If you had a higher interest rate here, it would increase the amount of money that you made. That'd probably be it. Cool. That's it. Cool. Simple interest. Interest is calculated once per year on the original amount borrowed or invested. The interest does not become part of the amount borrowed or owed. They don't add it in. Compound interest. Interest is calculated once per period on the current amount borrowed or invested. Each period, the interest becomes part of the principal. Simple interest, we calculate our interest by IPERT. Compound interest, future value equals present value, 1 plus rate and decimal to the time. Good work.